So you're probably wondering why I'm using this box in front of my face. This box is actually a microphone that I made out of a plastic cup and a magnet and a coil of wire. And I'm just demonstrating how um, a tin can phone can be used to basically to make a speaker if you have the right materials.
Okay, we're going to start off with your basic tin can phones. Um, got two tin cans here, string which you could use to send messages. These ones actually work a little better. These are just plastic phones. And I got a long strings here. In class, we would be attempting to find out which ones are the best, and you would find out that the plastic ones are better. The paper ones are actually best. And if you think about what a speaker is normally made of, a speaker is actually usually made of paper, so that might make sense. So we're going to transition to an actual speaker. And so this right here is actually a cup, just like the other plastic cup, but it has a coil of wire that is taped to the bottom, and then underneath it's got a magnet. And so I have actual electrical wires going in now, and there's my magnet set up, and the wires are going out to each side, and then you have a coil of wire inside of it. And so I'm going to try to take you in this kind of like logical journey from the idea of tin can phones and end up at the idea of how a speaker works. And basically how we send and receive information on a phone or something like that. It's the same basic principle, but it requires some explanation. I think that's for sure. So I'm going to go back to the computer and talk a little bit about that.
Hello. Okay, as you can see, I'm back. And this time I have a different computer setup. It's a little bit of a pain to work with that other setup. But so I'm going to attempt to take you from the tin can phone, hello, 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 which actually works quite well. You want to try this, get a friend, get a family member, and social distancing works well too because you can have a string that's way more than 6 feet, and get in another room. And the idea is that the string must be tight, and so if you can see here, the string actually has to be tight on the the string has to actually be tight as you talk. It can't be loose. Unlike this, actually is quite loose. It's not going to work. And this piece of cardboard is in the middle just to wrap it around. I just would unravel it, right, and go stand 15 feet apart and talk to the cone. But it's got to be tight. It's got to be tight. Right? You hear that? It's got to be tight. It can't be loose. Right? So, so what's happening there? I'm going to take you from the idea of transmission of mechanical waves to the transmission of electrical waves in something like a telephone or even a walkie-talkie, and moving on even to your cell phones or transmission of a radio signal from the radio station, something like that. So let's go to this, and so here's the first idea. Um, And basically, like I said, this is just mechanical waves, which are basically just vibrations of the string, and they travel from one spot to the next. They travel through the string. It takes some time. It's a mechanical wave. It doesn't travel at the speed of light. It does take some time to travel, but it happens pretty quickly. And if you talk into this, it will vibrate the bottom of this cup, and then it will vibrate the string. Then it will vibrate the bottom of this cup here, and then it will vibrate the string, and it will send the vibrations through the thing, and it will vibrate this cup. And so when this cup vibrates, it vibrates the air, and then the air vibrates your eardrum, and you can hear what's going on. And so let's move on to the idea of how that might work with electromagnetism. So it's the exact same way as what you have with exact same way as what you have with um, the motors. And so what I mean by that is, here you have a coil of wire right there, and then you have a magnet. And if I speak right now, my voice is vibrating the air. And in this very um, microphone, the air is vibrating parts of the microphone, which causes the microphone to vibrate, but it is actually vibrating a coil of wire next to a magnet. And well, not all microphones work in the exact same manner, but the same basic manner is that you want vibration between something that is a magnetic and a coil of wire. And what will happen is, since it's vibrating here, it actually will send pulses. It will send pulses through this wire, electrical pulses though. So they're not mechanical pulses. Well, they're kind of mechanical pulses because it's one electron to the next. So each electron will push the next electron, and it will push the next electron and push the next electron, and it's got to be through this circuit, right? So it's pushing electrons according to how I'm pushing here with my voice. And so since these electrons are going through this coil of wire, and the coil magnifies the amount of electricity, um, that will interact, and it will push against the magnet, and that's why the magnet is there. So it will push against this magnet in the exact same way that this magnet was pushed against by my voice, and so it will replicate the vibrations here. And so this will vibrate, and once it sends vibrations, it's going to be back to a mechanical wave. So you have two types of waves. You have a sound wave, which is a mechanical wave. Hello, 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 hello. And that is going to be actually changed by this into an electromagnetic wave. And the electromagnetic wave is just a wave of electrons going from electron to electron to electron to electron in this metal. And metals, as we know from before, have one of their properties is that they have a lot of free electrons, which means they move easily. And so this wave of electrons is going to swing through this coil, which amplifies the effect, and it's going to push against this magnet, and it's going to cause a vibration, which is identical to the vibration that came out. Will it be instantaneous? This one, wow, that's so cool, isn't it? This one is not instantaneous because it's a mechanical wave and it takes some time. This is also not instantaneous. Um, but it's very quick. It's pretty much the speed of light, and that's because electricity travels pretty close to the speed of light. From electron to electron to electron, it travels pretty close to the speed of light. So we have a mechanical wave like sound, and that's made into an electromagnetic wave by the interaction between the coil and the magnet that sends electromagnetic waves through the wire, and then it gets turned back into so from electromagnetic wave back into a sound wave, which is a mechanical wave, and traveling to your ears. Okay, so the last thing about this is, what if I want to make it wireless? Basically, this is the same idea, but I've cut the wire. And so what's going to happen now is same exact thing. My sound of my voice is going to vibrate the cup. It's going to vibrate the coil next to the magnet. Since these are close to each other, these vibrations will cause vibrating electrons to pulsate back and forth between this wire, which I'm going to call my antenna. Okay. Whenever you have an electron, and if that electron is vibrating, if it's going back and forth, that is actually the source of electromagnetic waves through the air. So all the electrons that are vibrating in this wire will actually put off in the air electromagnetic waves. Now, wait a second. Have you ever driven underneath, especially on it happens to me on Midas, and there's electrical wires over the top of Midas in the air. And my radio, sometimes I listen to the football game. I'm like trying to hear what the Niners are doing, the Steelers, my two favorite teams. Um, And if I go into those electrical wires, you get this interference. And the interference is because those electrical wires are putting off electromagnetic waves, like radio waves. And they're kind of so powerful there that they're interfering with the radio signal that I'm trying to listen to. So that's an example of electricity causing electromagnetic waves. But we're doing it purposefully here. This one, in this case, we're trying to put our voice pulsating as electromagnetic waves. And so my voice goes next to the magnet, next to the coil. It makes the electrons vibrate back and forth, and that is actually going to send pulses of electromagnetic waves through the air. Okay, now um, when these waves hit this other antenna, they actually are going to cause the effect that it is going to cause these electrons in this setup, and they're going to also vibrate, and they won't vibrate as strongly as the original ones because these are coming from my voice right here, but they will vibrate faintly in this wire. And since they vibrate faintly in this wire, and they're picking up the vibrations from my voice, they're going to vibrate in the same pattern as my voice was. And so with just a small amount of delay, it's going to vibrate here next to this magnet. Now you cannot feel the vibration in an electrical wire, right? You can't feel the vibration. This is an electromagnetic vibration. It's not a mechanical vibration. You can't feel that. Um, there are electrons moving. You can't feel that. I mean, obviously, if you grabbed a hold of naked wires, bare wires, and there's electricity going through, you would feel that. But that would be your electrons in your body going nuts. However, you can feel this vibration. This is a mechanical vibration. You can feel that. And if I put my hand on the string, I can actually stop the vibration. So this vibration all in here is invisible. It's electromagnetic waves. They're invisible. But once they get to be here, you can actually see the cup starting to vibrate. You can see a speaker move. And so that will turn it back into a mechanical wave. And so once again, we have the idea that sound is a mechanical wave, and it's going to vibrate physically, and it's not a very good C. Yeah, it's going to vibrate physically, and not much better. And it's going to make an electromagnetic wave by the interaction between the magnet and the coil, which is going to make electrons vibrate, which is going to electron vibrating. Whenever a charged particle vibrates, it causes electromagnetic waves through the air, radio waves, and these will go through the air, and they'll actually cause this antenna to vibrate. And so, since that antenna vibrates, if it vibrates strongly enough, you can make this thing vibrate the cup, and you will hear the sound come out the other side. And this is the beginning of radio transmission. I will explain in our next set of videos how a radio actually works, and I'll take you all the way from sunlight to radio waves in kind of a version of the law of conservation of energy. So let's see what we got here.